Hollywood has traditionally exaggerated several aspects of chemistry, including the effects of acid, as you have just seen. Movies portray acid as being capable of immense destruction, but we don't find that very realistic. We are determined to test if a strong acid can hold up to these claims by trying to melt a substance that is the average of every known substance, and many of you will find quite familiar: bacon. To test this myth, we are going to record and analyze the effects of concentrated hydrochloric acid on a piece of bacon, which is pretty analogous to most flesh. Tasty. To set up the experiment, we are going to pour approximately 200 milliliters of 3 molar hydrochloric acid, a strong acid, into a beaker. Strong acids fully dissociate in water, as opposed to weak acids, which only dissociate partially. HCl is a monoprotic acid, meaning only one H plus is dissociated. As a comparison, we are also putting bacon in 200 milliliters of 0.003 molar hydrochloric acid, which is about the pH of stomach acid. This will allow us to compare our results between the results with a very strong acid and normal stomach acid over 12 to 24 hours, which we will set in a time lapse in order to monitor and analyze the reaction between the bacon and the acid so you all can see it as well.
So, what do you guys think will happen in the reaction?
Personally, I think that the HCl will bleach all the color out of the bacon because it'll probably oxidize it, but it probably won't dissolve it in the time frame we've given it. Projecting this further onto like whole bodies, like the myth talks about, I think even less will happen because whole bodies have skin, which is hard to break down, and bones, which are hard to break down, and I don't know, it just seems that it wouldn't really work very well in whole bodies.
So, Jake, what's oxidation?
That's interesting. So oxidation is the loss of electrons as a molecule goes across a reaction. Very interesting.
That's a very interesting prediction, Jake. I think over the 12 hours that we're going to have the bacon submerged in the hydrochloric acid, nothing will really happen because the reaction rate between the hydrochloric acid and the bonds and the proteins, lipids, and all the other stuff in the bacon is very slow, so it would either require a lot stronger hydrochloric acid or a lot more time for it to break down.
That's interesting. What's a rate of reaction?
So the rate of reaction is exactly what's on the tin. It's the speed at which a reaction goes. It's affected by concentration and some other factors.
That's interesting. Yeah. What do you think, Sanjay?
So, I don't think that the HCl will be able to completely dissolve the bacon as seen in the movies because in the stomach, several enzymes and physical breakdown is also required to break down the bacon, and HCl is only one of those components.
Oh, okay. Yeah.
I don't think that it's going to make that much of a difference.
What do enzymes do for reaction rates?
So enzymes typically speed up the reaction rate, and they act as a catalyst to speed up.
So if the acid didn't have all the enzymes needed, it would go slower, right? Is that
Yes.
what that means? Oh, that's really interesting. Neat.
Chemically, what do you think is happening here?
Alright, so the most important thing at play here is cleaving bonds. We have two major kinds of bonds to deal with. Lipids, so fats, and then proteins. Both of them actually wind up being very similar. So we'll look briefly at lipids. You have a bond called an ester, which looks something like this. Basically double O, single O, and then something else attached to the other side. Now, so to cleave this, we need to bring in something that can knock off this group. And the way that works with an acid is, first the acid comes in and attaches a proton to this oxygen up here. This makes the whole molecule more electrophilic, which means it wants electrons. And that's good because over here we have water. And this oxygen is a nucleophile. It wants to grab on to something more positive. So what happens is the oxygen will come in. We will wind up creating a kind of four-part molecule here. And then eventually this bond will break and this part will break off. And you wind up with something floating off into the solution, and then over here a carboxylic acid.
We were only able to use a 3 molar sample of hydrochloric acid. If we had used a more concentrated acid, would our results have changed?
So what if you added stronger acid? I think you would see a little more damage to the bacon, but not much. So it would improve because, I mentioned, there's this step where the hydrogen comes in and protonates the acid to get the whole reaction going. And if there's more acid, that's more likely to happen because, the more stuff you have in solution, the more collisions that happen. But I don't think it's going to be a major improvement.
If we were to leave the bacon in the acid for more time, do you think that we would receive different results?
Okay, so a similar token here. If you have the reaction running for longer, you will have more time for it to take place. And I don't think the acid nor the water are going to be consumed fully in any reasonable amount of time. So I think the reaction will keep going for a while, and you'll slowly see more and more damage.
To bring it back to the myth, how do you think these results would scale up to humans or full animals?
No, it's not going to happen. The reaction is far too slow for this to happen in any reasonable amount of time, especially when you're dealing with something like a human body. There's so much thickness to that, so much mass, it's not going to happen. Even this sort of bacon is probably not going to melt.
Do you know of a substance that has the effects similar to that of acid seen in movies?
Alright, so you're asking, how do we make this work? So there actually is a way. It's a little dangerous. It's called Piranha solution. You probably don't want to lick it. It's a little dangerous. It's a mixture of sulfuric acid and hydrogen peroxide. Now, sulfuric acid is interesting because it really likes pulling water out of things. It's a powerful acid and it's also dehydrating. So, for example, you mix it with sugar. You've probably seen a video of this before. It will yank all the water out of the sugar, and sugar is just carbon and water. So you will wind up with a carbon skeleton. And that's kind of what happens here. The sulfuric acid in the solution will violently attack, organic molecules. The second part, though, is really interesting. As hydrogen peroxide reacts with sulfuric acid to produce oxygen, not O2, oxygen, a single oxygen atom. You probably know that molecules kind of want to have a full set of valence electrons so they're happy. This oxygen does not have a full set of valence electrons that is very unhappy. In fact, it's going to just kind of smash in whatever it can, break a few bonds if it has to. It's going to attach to something. And that is what allows Piranha solution to attack things like pure carbon, which is normally very unreactive.